Hello everyone, what's up? In this video we would be looking at problem E from today's Codeforces round number 667 div 3. So you can read out the problem statement by pausing the video. I will be explaining it in my own words. Yes, so we have 2D space. We have x and y axis, and we have been given endpoints. Endpoints, we have their coordinates as xi, yi, and they are placed at these locations. See what's the range of these points. 1 to 10 to the power 9. So they are only in this coordinate. These are the endpoints we have been given, and we need to place two platforms somewhere horizontally. That is, the platforms should be parallel to the x-axis, and the length of each of these platforms should be k. And the point when we have placed these two platforms, all the points in our 2D space will start falling down, that is to the negative y-axis. And if a point collides with a platform, or it intersects the platform, in other words, then that point would be saved. So we would be getting 3 points in this platform and 2 points in this platform, and let's say these points will fall down. These ones will fall down. We won't be able to save them if we have placed these our two platforms at these two locations on the red. So our aim here is to save as many maximum number of points as we can. Now there is one thing, the first thing which we need to observe here is we can place our platform at any place. The only thing is it should be parallel to the x-axis. So we can even place it down here at where y is equal to minus of 10 to the power 9, and we can even place our platform at this location. And at the end, when we have placed these two platforms, the points would be falling down. We can anyway place our platform down below the deepest point which we are having. So if you observe, the y coordinate does not really matter. Why? We do not care about the y coordinate. So now the problem reduces down to something where we are having multiple points on x-axis. Not even, let's not even focus on x-axis. Maybe we can. Okay, so we have these points and they have different x coordinates. Let's say x1, x2, x5 and xn. These are the coordinates, and we have sorted our points according to x coordinate. Okay, we have done this thing after the first thing we have done. Okay, now the problem reduces down to something. Here we need to find out two intervals of size k such that they should be gathering, or they should be consisting as many points as they can. So we need to gather as much points we can using these two intervals which are of size k. We can only have two intervals, and in the problem statement it has been mentioned that these two intervals can even overlap. That is, if we can even have this placing of the intervals. But if you see, the answer we would be getting after overlapping the intervals would always be less than equal to the answer we would be getting when the intervals are not overlapped. Because here the length, suppose our interval our intervals are not overlapped, the amount of area or the length we can cover on x-axis would be 2k. And if we are overlapping our intervals, let's say even by 1 unit, then the total length we can cover on x-axis by using these two intervals would be 2k minus 1. So it is kind of it is reducing the length we can cover using our two intervals. So answer in this case, when the intervals are overlapped, would always be less than equal to the answer we would be getting in the case when the intervals are not overlapped. So we would not be considering the cases where the intervals are overlapped because there is no need to. This was the second point which we need to observe. The first one was that the y coordinates does not really matter. Okay, so let's try to solve the problem what we can do. As I have mentioned, we have a set of points and they all have their x coordinate, and now I'm finding out two values. The first one is ending of point I, and the second one is starts of point I. Now what do these two terms signify is this will signify, because this is our space where our points are placed, and there is some point which is in between this range, and the coordinate of this point is array of I, because our points is stored in array of I. So this is the coordinate of this point. Suppose the point is this one. Now the ending I will represent the maximum number of points we can gather from one interval if the interval is placed somewhere on the left side of this point, and the start I will represent the maximum answer we can get or the maximum number of points we can gather using only one interval if the interval lies on the right side of this line. Okay, and yes, we to include this point, I am including the point which is lying on this line. I am including on this side, that is on the left side. So ending I also consists this line, that is the point lying on this line, but starts I also includes this point. So at what I would be doing for each of the points of my array, each of the locations of my points, let's draw them again. So for each of these locations, I'm finding out the maximum answer I can get from one interval from left side, and the maximum answer I can get from using one interval from the right side, and then I am summing up those two terms. Let's say from left side I'm getting one value L, and from right side I'm getting the answer R. So at each of these points, like even at this point, I am finding out these two values, and I'm summing up these two, and I'm doing this at each of these points. Suppose we also have a point at this location or at this coordinate of x. So even at this point, I'm finding out the maximum points I can gather from the left side of this line, and also on the right side I'm adding the value, and after finding out the value of L and R at each of these points, I'm taking the max of it, and that would be my final answer. Okay, now let's see how I am finding out these two values, that are ending I and start I. I will be explaining the ending I, and the similar approach can be used to find out start I. It is just the other way around. Yeah, let's see how we can find out the ending I. So we have this set of points. I'm using the sliding window technique to find out this ending I values for each of my points. I represent the starting index or the starting value of my window, and j represents the last value of my window. And suppose this is the value I. So I'm trying to find out the maximum number of points I can gather from one interval of size k if I'm including this current point. Okay, and this is I and this is j. So what I do, I find out the length of this the length of my current window, which is j minus I plus 1. I see if it is less than equal to k, then I'm storing this in my ending of j is equal to this value. And if I see that the window size is greater than k, that it means I cannot have this window as the answer for my ending I, as this interval size is greater than k, but we are only allowed to have the size of interval as k. So in this case I would be shrinking my window from left to right, so I would be doing I plus plus, and at this point I'm not updating the value of ending j, because I'm only updating the value of ending at the jth index, not at the ith. And if I see, if I'm at this point, that is the length of this window is less than equal to k, I will update my ending j, and then I expand my window to the right, that is I would be doing j plus plus, and I will keep on doing this for all these points. So these were the two cases. In this case I would be expanding my window to the right by incrementing j, and in this case where the length of my window is greater than k, I would be shrinking it and from left side to right side, that is I would be doing I plus plus. And for each of these points I am finding out the value of ending I. Now there is one more thing, the last thing I suppose. Suppose for this is the index j, this is the index I, and currently I found out that ending j is equal to 3, that is I am covering 3 points in this interval. But there might be a case where we have already found out another interval previously where we were covering more than 3 points. Let's say we were covering 6 points in an interval which we found earlier. So ending j will not be 3 in this case, it would be 6, because we are considering all the intervals which lies on the left side of this line, and we are taking the maximum value we can get from one interval, and that interval can be placed anywhere. It's just that it should be placed on the left side. So during my updation, that is where I am updating this value ending j, I'm also taking care of the previous values. So I am doing ending j is equal to maximum of ending j minus 1, or if the current window is covering more points than any other window which has been seen till this point, then it would be j minus I plus 1. The maximum value which will be going in my this ending j value. Now we would be doing the same thing for the start I. In this case we would be traversing from right to left, and we will do the same process again. I will not be explaining this, it is just the other way around. Explain what starts I and ending I represents. Now I hope you have understood my approach. Let's see the code now. First of all, I've taken the input. Y's coordinate don't really matter. So if we see there is only one point in our 2D space, we can cover at most one point, or we can save at most one point, and we just need to place our platform just below that point. So answer would be 1 in that case. That is a special case. Then we stored our x coordinates of all the points. At this point we do not care about the y coordinates, we have just neglected them. Now I've done some pre-processing where I'm finding out the value of start I and ending I. This is, as I have mentioned here as well, starts I. It represents the maximum number of points we can gather in one interval of size k in the region array I to infinity. That is, suppose this is the coordinate of array I. So any point lying in this region, any interval lying in this region, and it is covering the maximum points, that is the answer I am saying in start I. And ending I represents maximum points we can gather in one interval size k in the region minus infinity to array I. That is in this region. This region, if any one interval which is covering more points than any other point interval present the left side of this line, I am storing that answer, that number of points as answer in this ending I variable. And how I am doing it, I am using the sliding window approach, which I have tried to explain. Here initially I and j are both 0. If I see the difference between the x coordinates is less than equal to k of my window, that is here my window, this is I and this is j. Now array I is the coordinate of this point and array j is the coordinate of this point. So if I see that is less than equal to j, I can just take, I can either take the maximum of any other interval which I have found previously, or the current interval which is gathering j minus I plus 1 points, or yeah, I will take the maximum of it. And if it is the first interval, I do not need to take care of any previously found interval, as it is the first interval. So I'm just updating its value to j minus I plus 1. Then I expand my window in this case, and if I see that array j minus array I is greater than k, that is the window which I am currently taking, the length of this window is greater than k, then I need to shrink it. I will shrink it from left to right. I will do I plus plus in this case. Yep, I've done this thing here. So in this, after we come out of this loop, we would have found out the value of ending I for each of the points. Similarly, I've done the same thing for starts I, and in this loop I have traversed from right to left. It is the same thing if you see. Now after finding out these two values, I'm just moving along my x coordinates, that is moving along my x points and looking at the x coordinates and taking the max of L and R, which I explained earlier over here. So for each of these points, I am taking one interval from left side and one interval from right side for each of the points. And this is L, this is R. L is the number of points I am covering using this interval, and R is the number of points I am covering using this interval. This is the maximum value I am getting from this side. This is the maximum value I am getting from this side. Doing this at each point, and the answer would be L plus 1. At the end, I am taking the maximum of it because we are considering each of the points. Yep, start I plus 1. At the end, we are printing the answer. So yeah, it turned out to be a long video, and yep, if you liked it, then please like and share our videos, and do subscribe to our channel, as I've seen around 85 to 90% of our viewers are not subscribed to our channel. So yes, we will see you in the next videos. Till then, take care. Sayonara.